Testing, testing, is this thing on? Okay, children, today you are going to learn about sequences. There are two types, arithmetic sequences and geometric sequences. You will sit down and listen. So the first type of sequence we're going to talk about is arithmetic. And the key vocabulary you need with arithmetic sequences is that they have a common difference. Common difference. The official definition is a sequence of numbers in which each term is the result of adding or subtracting the same number to the preceding number. So we're going to give you an example, and then later on we'll give you a couple more examples. So this first one, we have a 12, a 7, a 2, a -3, and -8. Well, if you look at these numbers, they want us to find out the next two terms that are going to come up. And if you look, basically you're subtracting 5 from each term. 12 minus 5 gives you 7, 7 minus 5 to 2, and so on. So if we continue this, if you subtract 5 from -8, you're going to get -13. Now remember your integer rules for this. -8 minus 5 is -13. And if you keep going, it's going to be -18 for that final missing term. Basically, you're scooting down the number line 5 units to the left each time. So the sequence here has a common difference of 5. You're subtracting 5 each time, so there's a common difference of 5. All right, the next type of sequence you're going to learn about is a geometric sequence. Also, the keywords for this is going to be they have a common ratio. So a geometric sequence is a sequence of numbers in which each term is the result of multiplying or dividing the same number by the preceding number, the one that comes before. So we're going to give you some numbers. 3 to 9, 9 to 27, 27 to 81. We're not adding the same thing. What we're doing is we're multiplying each number by 3 to get the next number. So 3 times 3 gives you 9, 9 times 3 is 27, 27 times 3 is 81, 81 times 3 gives you 243, and then taking that one times 3 gives you 729. Now when you take each pair of numbers, if you look at the 3 to 9, the 9 to 27, 27 to 81, if you get those ratios in lower terms, they all break down to the same ratio. They will all break down to a common ratio of 1 to 3. So now what we're going to do is give some visuals with these different types of sequences. With arithmetic sequences, if you graph all the different numbers on a number line, the terms are going to stay the same distance apart. They'll always have the same amount of spaces in between them. And you just count those spaces, and that's the common difference. That same difference is called the common difference. For geometric sequences, when you graph them on a number line, the different points will either get further apart or closer together. And that space that's being multiplied or divided by is called the common ratio. The number that's being multiplied or divided by is the common ratio. What kind of sequence would this be? If we have a number going to the next number, going to the next number, going to the next number, and so on, what kind of sequence would this be? This is going to be an arithmetic sequence because it has a common difference of 4. Do you see how they're all 4 apart? That means it's jumping the same amount. It's a common difference of 4. What is the expression to figure out the next term? What are you doing to each number to figure out the next one? Well, in this case, we're taking a number, we'll call it n, and we're adding 4 to it each time. So n plus 4 is what you're doing. That's the expression to figure out the next term. So let's do another one of these. We've got a number, and it's pretty close. then it gets a little further apart, and it gets even further apart. So we can rule out that this is going to be arithmetic, because arithmetic is when they stay the same distance apart. So that means this pattern, or this sequence, is going to be a geometric sequence. What is the common ratio? Well, if we look at it, first of all, it's 1 apart, then the next one's 2 apart. So it's gradually increasing, which means you're multiplying by something. Basically, this is a 1-to-2 ratio. It could also be considered a ratio of 2. A couple years ago on an SOL test, they listed a ratio as a single number, which goes against the definition of ratio, but I won't go there right now. 1 to 2 is the best answer. What is the expression to figure out the next term? The next term, to figure it out, you'd basically take your previous term and multiply it by 2. If the distance between each term is doubling, there you go. You're going to get 2n. All right, how about this one? We're starting over here and we're going to the left. Looks as if we are doing the same amount. They're not getting further apart. They're staying the same distance apart. It's an arithmetic sequence. This means they have a common difference. How far apart are they? They're 3 apart. They have a common difference of 3. Now, what is the expression to figure out the next term? Well, you're taking each number and subtracting 3 from it. So n minus 3 is what you're doing. Finally, we have one more. We've got this. Whoa, that's a big jump. Let's see. Oh, then it gets a little closer, then a little closer. Well, it's a geometric sequence. It's changing the distance. The common ratio, let's see, first it's 25 apart, then 5. Looks as if we're dividing each number by 5, which would mean it's a 5-to-1 ratio, or basically to figure out the next number, you are dividing by 5, 1/5 of the number, a few different ways to show it, but those all mean the same thing. You're taking the first number, dividing it by 5, and so those distances are becoming smaller and smaller. That's it. Hope this helps.